Hello and welcome to this video on binomial distribution. Now, binomial distribution is something that you may well have seen before, as after all it is in Core 2 in your AS Maths. However, in Core 4 it changes slightly. In Core 2 you will be familiar with a binomial expression that looks like this. I.e., it will have a power of x greater than 1. You know how to use your NC, X's, etc. to get it all done. Now, here's where it differs in Core 4. Now, it differs in Core 4 in the following ways. Now, if we look at question A, and I hope you can all see properly on the video, you will have minus powers, and you will have fractional powers. Now, fear not, there is a way of doing this. It is not as horrible as it looks. Now, in this case, we use a formula in order to do it. Now this formula is slightly different to the one that you're used to, as I will write underneath. This formula is 1 plus nx plus n, lots of n minus 1, x squared over 2 factorial, plus n minus 1, n minus 2, x cubed over 3 factorial. This is for an expression that looks like 1 plus x to the n, in which case, what most common binomials will look like. And that is the formula that we use. Now, as you will notice, I should put dot 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 then, this will run on for infinity, so they will usually ask you in a question to find the first couple of terms. So if we take question A and see what we can do. Right, so 1 plus 2x to the minus 2. So we can substitute some values in. So it's 1 plus minus 2x plus n. Now remember, n is our power, and our power to start with is minus 2. So really what this should have been is minus 2x times minus 2 plus minus 2 minus 3 2x squared over 2 factorial plus, excuse the fact that I cannot fit everything on one line. I appreciate that's annoying, but bear with me. So now we want the third term, the x cubed term, so that is minus 2 minus 3 minus 4, and then we want 2x cubed all over 3 factorial. Now I apologise for making this bit not particularly clear. I will rewrite it so it's 1 plus 2x and minus 2, because minus 2 is the power and that's what we want to times it all by. So simply shove that in your calculator. So we have 1 minus 4x, and then we must do minus 2 minus 2 minus 3, then times it by 2 squared all over 2 factorial, which comes to 12x squared. And then finally we want our x cubed term, which will be a minus term. Minus 32x cubed. Right, to quickly recap, what we have done is we have taken this formula here, which I will now attempt to draw a very badly drawn box around, and we have simply taken it and we have simply substituted values in for any equation that looks like that, 1 plus x all to the power of n. So when we have a coefficient of a, it'll be ax squared, ax cubed, and what you do is you times it by n and then decreasing powers of n over effectively the number that you're decreasing it by factorial, if that makes sense. We're going to go on to another question, and hopefully you'll be able to understand this one just as well. This one is slightly simpler, so you'll probably get my meaning a bit better. 1 plus x to the minus 3. Now this one looks exactly like 1 plus x to the n, so we shouldn't have any problems with this. This goes to 1 plus minus 3, lots of x, plus minus 3 minus 4 x squared over 2 factorial plus minus 3 minus 4 minus 5 x cubed over 3 factorial. Now then, Spanning this out, we get 1 minus 3x plus 6x squared minus minus 10x cubed. Now, as I said earlier, they will only ever ask you to do usually to the powers of x cubed, because as I said, this formula will go on for infinity. Now we're going to look at a slightly different type of question now, and you can probably tell me what's wrong with it, or why it looks different. I'll rewrite it just so you can all have a look better. 4 plus x to the half. Now, why is this different? Now, there's a couple of reasons why this is different. One, it has a fractional power, and two, it does not look like 1 plus x to the n, as there is a 4. So, here's the question. How do we deal with it? What we do is we take 4 out of it. So what we have is 4 to the half, lots of 1 plus x over 4, all to the power of a half. Now then, 4 to the power of a half, as many of you will know from your amazing indices knowledge, is square root of 4, which is 2. So what we have in this case is we can rewrite this as 2 lots of 1 plus x over 4 to the half. And then simply we can expand outwards to whatever term we want. So in this case we're going to have 2 lots of 1 plus 1 half 1 quarter x plus 1 half minus a half 1 quarter x squared over 2 factorial plus, oh look, we can even fit it on one line here, 1 half minus a half minus 3 over 2, I can just fit it on, note, 1 quarter x cubed over 3 factorial. So what we have is, we have 1 half times 1 over 4, so that's 2 lots of 1 plus x over 8. Bear with me here because I still need to type everything into my calculator, as I would not expect anybody to be able to do this in their head. If you can by some miracle, I'm incredibly impressed, and I assume you're going to do very well in your A-level exams. So best of luck to you. Minus x squared over 128 plus, finally, because for the x cubed term, what we're going to do is we're going to do 1 half minus 1 half minus 3 over 2 1 over 4 cubed all over 3 factorial, which is going to give us x cubed over 1024. And then finally we can expand this out to be 2 plus x over 4 minus x squared over 64 plus x cubed over 512. Right then, now there's one last bit we've missed, which I've done on all 3 questions deliberately. Now, if you are to look on the formula for binomial, you will notice that it says that the modulus of x must be less than 1. Now, in many of these examples, that will be the same, but for some of them, we might need to state what x must be in order for this formula to work. So if we go back to our first question, it is 1 plus 2x to the minus 2. Now, obviously, x can't be 1, because 1 plus 2 is 3, so that's not going to be an issue. Well, that's going to be a problem, sorry. So what we can do is this. 1 plus 2x equals 0. 2x equals minus 1. X equals minus a half. Therefore, we know that the modulus of x must be greater than a half. Now, the reason why it is modulus is greater than a half and not minus a half is modulus takes away any negative signs in it. And this is important. You must say that because that is the values of x for which these formulas are valid. Values of x for which this formula is valid for, yes. For b, it is just simply x must be less than 1. And for c, now c is where it gets a little tricky, is we must use the formula that we've changed, the 1 plus x over 4. So that is going to make it so that modulus of x must be less than 4, because it's a quarter, so you need 4 lots of stuff to make 1, effectively. So yeah, that is how you do binomial in Core 4. I hope this is useful, and I'll see you next time.